Welcome to week 9 practice problems. First problem says, which of the following is true about the scores? All right, so this problem has a table. It's got 4 different students and their scores on project A and their scores on project B. And all the questions, answers, I suppose, start talking about mean, medians, and those kind of things. So what I would probably do is just find the median of each thing. Find the median of A, find the median of B. So remember, the way we do that is we add up all the numbers and divide by the number of numbers. So first thing I'm going to do is pop over to my calculator here, and I'm going to do, be able to see my numbers here. All right, so go back to second mode. So I'm going to do 55 plus 60 plus 95 plus 80. And then I'm going to hit enter, and then I'm going to divide that by 4. So that means that the mean of A was 72.5. Do the same thing with the other side. So 85 plus 100 plus 78 plus 72. So 185, that's the sum of the first two numbers. And then 80 and 70 is 150. So I just kind of paired them up to make the addition easier, but same thing. Add all the 4 numbers up, divide by 4, you get 83.75. Mean of B, 83.75. So the mean of A is 70. That's not true. Okay. D, the mean of both scores is 70. Well, I'd have to average these two together, and I can tell right now that it's not going to be 70 because the average of these two, which would be the average of the total, isn't 70. So I can cross that one off as well. Last thing says the mean of project A is lower than the mean of project B. So that is actually true. Okay. Now these are starting to talk about median, and that's a little bit different. So I would have crossed out the highest and the lowest and then taken the average. So the median would have been 70 here. Cross out the highest, cross out the lowest, average these two. We would have gotten 83. Excuse me. What would that be? 4 and 4, so 3.5. So 81.5 would have been the median here. All right, so just, know how to use median and how to use mean, and that's it. Okay. Let's see, did I actually answer that question? Yes, the answer is E, the mean project A is lower than the mean of project B. All right, a bag contains 4 green balls, 3 red balls, and 5 yellow balls. What is the probability that 2 balls drawn at random are both red? Okay, so we want them both to be red. So you can think about it as pulling 2 balls out at the same time, or you want to think about the first one being red and then the second one being red. And since we're technically pulling them at the same time, we're going to do without replacement. We're not going to put them back in there. That means the numbers are going to change. So we've got 4 green, 3 red, 5 yellow. That's a total of 12. So if I pull out a red, the first one is a red, that's going to be 3 out of 12, or 1/4. Now, the probability of the second one being a red now is only going to be out of 11 because I've already pulled 1 ball out. And there's also not 3 red left because I pulled 1 out. There's only 2 now. So I can kind of show that right here. There's only 2 reds. The 2 reds out of a possible 11. Remember, these both can happen at the same time. So I multiply them together. Also, I'm doing a red, and means multiply. So I get 6 over 121. Let's see, this reduces to 1 over 22. So our answer choice is B, 1 over 22. All right, next problem. As I am laying out my clothes for tomorrow, I have 3 shirts to choose from, 5 ties, and 3 pairs of pants. How many possible combinations of outfits do I have? All right, this one's pretty simple. It's going to be 3 times 5 times 3. It's how many different combinations, and I have 3 different choices. So it's sort of like I have 3 blanks. I have a shirt blank, a tie blank, and a pants blank. I have 3 choices for this, 5 choices for this, 3 for this. multiply them together because they can happen at the same time. It gives me 45, so answer choice D is correct. All right, a dice is rolled. What is the probability that a roll of 3 will not happen? All right, so a couple ways to do this. You could just realize that the probability of a 3 happening is 1 out of 6, okay? That means the probability of not a 3 is going to be 1 minus 1/6. It's the thing that's left. I'm going to rewrite this because I don't think you could see it. 1 is 6/6 minus 1/6 is 5/6. So that's our answer, E. Now, alternately, you could have said, well, what's the probability of not being a 3? How many ways could that happen? Well, that could happen. It could be a 1 or a 2 or a 4 or a 5 or a 6. That's 5 out of 6 possibilities. And that's also the same thing. A couple ways to do that. All right. Next question. The airline reports the number of late flights each day for 3 days. They also record how long the flights were delayed. The results are in the table below. So we've got this table with 1, 2, 3. Those are the different days. You've got the number of flights delayed and the length of the delay. Question is, what can you accurately calculate from this information? All right, so the answer choices are mean, median, and mode. First off, the mode. You can tell which one happened the most. You can tell the 3-hour delay happened more than any other of the different hour delays. So I can definitely say I can calculate the mode. So it's either 1 only, 1 and 3 only, or 1, 2, and 3. It cannot be only 2 or 3. Next thing would be the mean, the average. So remember, I don't know how many 1-hour flights I had. It says less than 3, so I could have had 0, I could have had 1, or I could have had 2 1-hour flights. And then I've got a bunch. So am I going to be able to calculate the sum accurately and the number n? I don't know the total number of delayed flights I have because I don't know how many flights were delayed on a specific day. So on day 1, there was less than 3 flights delayed. They were all 1 hour long. So I don't know n, and I certainly don't know the sum. So I actually can't calculate number 2 very well. So I can say it's not going to be choice E. So I'm down to A or D. The question is, does choice 3 work, the median? So let's look at these 3 different cases. What would N be if I had 0 flight delays on day 1 that were all the 1-hour flight delays? I would have 15, right? Because I'd have 7 and 8. N would be 15. Remember how to use N plus 1? So 16 divided by 2 is 8. The 8th number in this list would be the median. So if you look at the first 7, they're all 2 hours. These are all 2s, and the 8th number would be a 3-hour delay. That means that in this case, I would calculate it to be a 3-hour delay as the median. Okay? Now, what if there was one 1-hour flight? Okay, what if there was only one 1-hour flight? That would mean that there's a 1 here, and 7 and 8. That means the number of data points is going to be 16. That means that I do n plus 1, 17 divided by 2. The 8.5 number will be my median. So the average of 8 and 9. Okay? Well, the 8th number is actually going to be a 2-hour flight. That's the 8th number, because I had 1 that was a 1 hour, and then 7. That means the 8th number was a 2-hour, and the 9th number was a 3-hour. So the average of 2 and 3 is 2.5. So under this condition, now I've got a 2.5-hour median. All right, and if n was 2, we would have 2 and 7 and 8. That makes 17 total flights that were delayed. I'd go to the 18 over 2 number to find the median. So that's the 9th number. And in this case, the 9th number would be a 2-hour flight. There's 2 before it, and then 7, the 9th number would be a 2. So that means it's a 2. So I get 3 different answers. I don't think I can accurately calculate this without knowing exactly what that number is in that chart. I don't know the number of flights that were delayed on day 1. So I don't know if I can accurately calculate that. So I think then my answer is going to be A, that only the mode can be calculated from this chart. All right, a jar of candy is filled with different colored hard candies. There are 4 blue, 8 red, 6 green, and 1 orange candy. 3 candies are drawn at random and eaten. If the 3 were if the three that were chosen were one blue and two red, what is the probability the next candy drawn will be red? Okay. So this looks like we're just really calculating the probability the next candy will be red. Okay. These other draws have already happened. So we don't actually have 4 blue, 8 red, 6 green, and 1 orange because we've drawn 3. There was 1 blue and 2 red. So 1 blue means we only have 3 blues left. 2 reds mean there's really 6. So really I just need to know the probability that the next candy will be a red, given that those other things have already happened. So my numbers have all changed. So the probability of red would be 6 out of the total. And if I count the total of all these, I'm going to get 16. So 3/8 is going to be the probability that I can draw red after these other things have already happened. So answer choice A is correct. All right, how many ways can 5 people be placed into a row of 5 seats? All right, we've got 5 seats. Those seats don't really change location. We've got 5 people. How many people can I put in the first seat? Well, I have 5 different choices. Now that one person's seated, I only have 4 more choices. Then 2 people are seated, so 3, 2, and 1. Remember, these can happen at the same time, so I'm going to multiply. And if I multiply that, I get a number. But really, if I look at my answer choices, none of them are just a number except for 15, and it's not going to be 15. But I just remember that this notation is 5 factorial. 5 times 4 times 3, all the way down to 1, that's 5 factorial. So answer choice B is correct. This one here kind of looks sort of like something we've done, but it's not really anything. This doesn't look like anything we've done, and this is like if there was one less. So none of those are going to be the correct answer. So it's going to be answer choice B. All right, at a certain manufacturing company, they recorded the number of days missed by their employees last year. A frequency table is given below. Find the mean of the number of days missed rounded to the nearest hundredth. All right, so basically we see the table says the number of days missed. There's a column there, and then there's a column that says the number of employees that missed those number of days. So we had basically, this is what the list looks like. A bunch of zeros, right? 35 zeros in that data set. Then a bunch of ones, a bunch of twos, and then a bunch of threes. That's really what the data looks like, okay? So if we want to find the mean, we need to find the sum of all those numbers. Now, instead of adding up a bunch of zeros, I'm just going to do 0 times 35, which is 0, okay? Instead of adding up all these ones, I just multiply 1 times 26, since there was 26 of them, right? 2 times 45 is 90, 3 times 17 is 51. So if I add these together, I will get the total number of days missed. So it's the sum of all these data points together. Okay, so 167 is my total. So that's my sum. So 167 divided by n, the number of data points. So how many zeros were there? Well, it was 35. How many ones? There was 26, 45 twos, and 17 threes. So basically, I add up that vertical column. If I add that together, I will get, let's see, 23, carry the 2, 4, 7, 8, 12, 123. So there's 123 data points that added up to 167. So pretty simple division here. 167 divided by 123. That's going to give me 1.357. It says round to the hundredths. So 1.357. The hundredths place is the 5. So we look over one more and see if this number gets us closer to 1.36, which it does. So we don't round down, we round up to 1.36, making answer choice B our correct answer. All right, assuming x is a positive integer, what is the mean of x, 2x, 3x, and 20x? All right, mean problems, they all work the same, right? We calculate the sum, so we add up all the data points and we divide by the number of data points. There's 4 data points there, so I do x plus 2x plus 3x plus 20x divided by 4. Well, I have 1 plus 2 is 3 plus 3 is 6 plus 20 is 26x divided by 4. That gives me, let's see, 6.5x. So 6.5x is my mean of those numbers. If there are 112 candies in a jar, red, blue, and yellow, and the probability of pulling out a yellow candy is 1/8, and the probability of pulling out a blue candy is 1/4, then how many red candies are in the jar? All right, so there's only red, blue, and yellow. Those are the total three things. So the total probability should add to equal 1. Well, red, yellow was 1/8. And the probability of a blue was 1/4. So we want to know what the probability of red is. So we know that 1/4 plus 1/8, it's really like 2/8 plus 1/8. That's 3/8. So what number plus 3/8 equals 1? Well, I can either know what the number is or I can use algebra to solve. I can just subtract 3/8. So I get 5/8. 5/8 plus 3/8 is 1/8. It's the total probability there. Okay? So 5/8 is total. Now it does say how many red candies are in the jar. So if I know the probability is 5/8 and there's 112, okay, basically 5/8 of some number, 112, is equal to X. It's the number of red candies. So 5/8 of our total should equal the number of red candies. So 5 divided by 8 times 112. This is an easy problem on my calculator. All right, 5/8 times 112. I get 70. So there are 70, which is answer choice C. There's 70 red candies in my jar. All right, what is the probability of drawing a king 3 times in a row if you put the card back in the deck after each draw? All right, so we're replacing here. We're doing with replacement, which means my bottom number will not change. So how many ways are there to draw a king? There's 4 kings out of 52. Remember that simplifies to 1/13. That's the probability of drawing a king. Now if I put it back in, the probability doesn't change. So that if I draw again, 1/13 times 1/13, if I put it back each time, the probability should be the same. Remember, these things cannot happen at the same time, or I guess they're separate. So they're multiple events. We multiply when we do multiple events. So that's why we're going to multiply. 1/13 times 1/13 times 1/13. All right, a student wants to average a 90% on their 3 tests this semester. On the first test, they get an 83%. On the second, a 91%. What's the minimum score they need to get on the third test to get at least a 90% average? Okay, so this problem is done in 2 ways. You set up your little equation and solve, or we can think about it as like this balance beam, right? I want to get a 90% average. Well, on one of the tests, I got an 83. Okay, that is down 7 from the average, 7 below the average. On the second test, I got a 91, which is 1 above the average. That means I need to have a score that has +6 because these need to sort of even out to balance out exactly at 90. So what number is 6 above the average? Well, it's 96. So 96 is going to be our answer choice. That's an easy way to do that problem. There's another way. You could set up an equation. You know that the average of 90 has to equal the sum. So the first test was an 83. Add that to the second score, 91, plus the third score, which we don't know, so we leave that as a variable, divided by 3. That average should be 90. There's our equation. How do we solve it? Multiply both sides by 3 to get rid of that 3 there. That makes 270. I can go ahead and add these two together. I get 174 plus x. Then I subtract 174. I'm going to get 96. Okay, so you can set up an equation to solve as well. I kind of like this balance beam thing. It's pretty quick and easy. Just got to make sure it all zeroes out around the average. You got to have the same amount of difference above as you have difference below. Pretty easy. All right, in a small school, 30 people take French class and 55 take Spanish. If 75 take French or Spanish, how many take both French and Spanish? All right, so this problem, you got to have a Venn diagram. All right, this is a very simple problem with a Venn diagram. You've got French, you've got Spanish, then we're starting in the middle. In a small school, 30 people take French, 55 Spanish. If 75 take French or Spanish, how many take both? So we actually don't know what that number is. So in this case, we can't really start in the middle. So I would just remember that there could be duplicates, right? The number of duplicates is what X is. It's the number of people you counted when you counted the French and when you counted the Spanish. Think about it. If you have 30 and then you have 55, that's 85. There's only 75 people taking the classes. So you overcounted by 10. That means the middle was 10 because you counted it twice. So you can kind of reason through it that way, or the formula, the number of people that took French plus the number of people that took Spanish minus the number of people that took both should equal the total, or the number of people that took French or Spanish, okay? So the number of people that took French, that's 30, plus the number of people that took Spanish, that's 55, minus both, that's what we want to know, that should equal 75. So you get 85 minus a number equals 75. It's clear to see that that number has to be 10. So 10 people took both. So choice A is correct. All right, if n plus 1 factorial is 7 times larger than n factorial, then what is the value of n? All right, well, let's think about this. If, let's say n was equal to 4, right? That's one of our answer choices. That would mean that we would have n factorial equals 4 times 3 times 2 times 1. So n plus 1 factorial would be 5 times 4 times 3 times 2 times 1. It's just one bigger. So notice this is the same thing here, right? This is n factorial, this is n, it's 5 times as big. We want it to be 7 times as big, which means that n must have been 6. Because if n factorial is 6 times 5 times 4 all the way down, and n plus 1, right? If n was 6, then n plus 1 would be 7. 7 factorial is 7 times 6 times 5 times 4, all the way down. So it's the same thing, it's just 7 times as big. That's kind of a weird problem, but it really just makes sure you understand what factorial is. All right, how many 3-letter combinations are there that don't have repeat letters? All right, so we know that 3-letter words would have 3 spaces. You can't repeat the letters. How many letters are there? There's 26 letters. If you can't repeat, you've already chosen one. You must have one less, and then you'd have one more less because you've already used up 2 letters. And then we remember that the multiplication rule is in effect here. So 26 times 25 times 24, or choice C. Now, alternately, right? Since order matters, right? Cat is going to be different than tack, which is going to be different than act, right? Since order matters, we know that we could solve this using a permutation, right? I have more letters than I have spaces, so I could use a permutation. N would be 26, and R would be 3. I have 3 places and 26 letters to choose from. So let's try this. Let's get our calculator. And let's do math over to probability, down to permutation, and let's do 26, choose 3. And that gives us 15,600. Now, of course, that doesn't make sense because we don't have any of these, but you could easily check them, right? 26 factorial, 26 math probability, number 4 factorial. That doesn't match. That's a huge number, right? That's 4.0 times 10 to the 26. That's 4 with 26 zeros. It's a big number. Not that one. Could it be 26 times 25 factorial times? Well, if 26 factorial was too big, it can't be that one. You see, D would be 26 choose 24. That doesn't make any sense. And then what if it had 26 factorial divided by 3 factorial? Well, if I go up and hit enter, that's 26 factorial divided by 3 factorial. That's going to actually be 6 because it's 3 times 2 times 1. It's still too big of a number. So you could check that 26 times 25 times 24 is actually the only choice that works. 26 times 25 times 24 gives you that 15,600. Okay? All right. The mean of 6 numbers is 31. Find the sum of the 6 numbers. All right, thinking back, the mean is the sum divided by the number of numbers. It's asking us for the sum, which means we must know the mean and then the n. So 6 numbers, so n is going to be 6, and the mean is 31. How do I solve for sum? I just multiply both sides by 6. The sum is just 6 times 31, which is 186. So answer choice D. All right, in a certain small town, 180 people like cherry soda only, 80 people like root beer, and 20 people like both cherry soda and root beer. How many people like cherry soda or root beer? All right, so a couple things here. Small town is 180 people that like cherry soda only. So first off, this is a perfect candidate for the Venn diagram. Cherry soda, root beer, 100 people like cherry soda only. So that means only 180 people are only in that little area, not this center area here, because they only like cherry. They don't like root beer. It says 80 people like root beer. So can I put an 80 right here? Not really, because I have to say 80 is this and this. The whole thing is 80. So I'm actually not allowed to put 80 there. It says 20 people like both cherry soda and root beer. So 20 like both. That means if there's 80 in the whole circle, I've already used 20, there's only 60 left over. See what I did there? 80 like root beer, that's 80 right there, the 20 and the 60. 20 in the middle, 60 on the outside, that's 80 total. The question is how many people like cherry soda or root beer? That's the sum of these three things. That's the entire piece, the whole shaded in area, which is 180 plus 20 plus 60, which adds up to be 260 people. So 260 people like either cherry soda or root beer. All right, what is the probability of drawing a red card or a king in a single draw? All right, so we've got our or here. Or means I need to add. So the probability of a red plus the probability of a king. That seems pretty straightforward. Probability of red is 1/2, because there's half red cards. Probability of king, there's only 4 out of 52, which simplifies to be 1/13. So if I added those together, I would have 15/26, which is answer choice E. Answer choice E is not correct though, because I've got duplication. There is a card that is red and a king. So I have to take away the probability of red and a king. Okay? Well, there's only 2 red kings. So 2 out of 52. So 1 out of 26. So minus 1 out of 26. So if I make common denominators of 52 here, I know this is 2 out of 52. This is 4 out of 52. And this is 26 out of 52. I have 26 plus 4, that's 30, minus 2 is 28 out of 52, which reduces to, if I divide it by 4, I get 7/13, and answer choice D is correct. You've got to be careful of this duplication. It gets me into a lot of trouble sometimes too. I'm like, oh, it's easy, it's or, it's this plus this. Watch out for those things you counted twice, because when you found the probability of the red, you counted those red kings. When you found the probability of all 4 of those kings, you counted those red kings. So you need to take away those red kings that you added twice. That's why we subtract that and probability. All right, there are 3 colors of balls in an urn. The colors are white, purple, and green. If the probability of drawing a white is 1/3 and the probability of drawing a purple is 2/5, then what is the probability of drawing a green ball? All right, there's only white, purple, and green. Probability of white is 1/3. Probability of purple is 2/5. So we don't know green, but we know that those are the only 3 colors, so they should have a total probability of 1 when I add them all together. So basically, I need to find out what 1 minus the sum of these 2 numbers is. So if I got common denominators of 15, this would be 5/15. This would be 6/15. That's 11/15. If I take away 11/15 from both sides, I get 4/15, which is the probability of selecting a green. I don't actually know how many greens there are, or purples or whites, or even the total. I just know there's 3 different colors, and if I know the sum of those probabilities should equal 1. All right, which has the greatest value from the data set given in the stem/leaf plot below? The mean, the median, or the mode? All right, so what's bigger, the mean, the median, or the mode? Well, first of all, don't forget, when I look at this stem plot, it's really saying 34, 36, 44, 44, 51, 58, and 59. That's actually my data set, smushed down into this little stem and leaf plot. So the mean is where I add up all these numbers and divide by however many there are. There's 1, 2, 3, 4, 5, 6, 7 numbers. So if I get out my calculator, add them all up, 34 plus 36 plus 44 plus 44, 51, 58, and 59, I get 326. Okay, when I divide that by 7, I get a mean of 46.57. All right, the median, well, that's pretty easy. I just start knocking off numbers, right, till I get to the center. The center is 44. In the mode, what number happens the most? Well, 44 happens the most. So I can see the greatest value is my mean. Now remember, I could have done this sort of from here without actually writing them out. I can see that I can cross off the greatest, the lowest, next greatest, next lowest, next greatest, next lowest. I see that 44 is the middle number. Of course, the mode, right, since I saw that there was those 2 4s right here, these 2 4s, that means 44 happened twice. It's the only number that happens twice, so it's obviously the mode. So that's pretty straightforward. All right, that's all I got for you today. Appreciate you being here, and we will see you next week.